So today we will start discussing pictorial drawings. Now we will do some discussion today about some types, and next class we will continue because there are several. Okay, we will not cover them all in one class. So, what are pictorial drawings? So, this is here a pictorial, for example. So, they are 2D drawings that look three-dimensional. Okay? So, this is not a real three-dimensional object. It's two-dimensional, but it looks 3D. Okay? For what is its purpose? Well, pictorials are effective at what? Illustrating design ideas. So, if you want to draw, for example, something, it's easy through a pictorial to illustrate what you are doing. And it helps us visualize drawings. Like, for example, this is here what? This is a multi-view orthographic drawing. We have a front, the top, the right side view. Now, if we didn't have this pictorial here, for example, and we just look at this, okay? Now, the object is fairly simple. It's easy to imagine what it looks like. However, if the object becomes a little more complicated with more details, just looking at the multi-view drawings becomes a little difficult to imagine what the object will really look like if it is in 3D. So, pictorials are always included, okay, in engineering drawings to help visualize these multi-views. Okay, so it's very helpful in this regard. So, now there are many types. In the past, we just knew about one type, the isometric. Okay, isometric drawing is one type of pictorial representation that is used in engineering drawings when you have orthographic drawing, and the isometric is usually always included most of the time. So, but this is one type only. So today we will actually focus on the isometric, but in more detail, and we will have a look just what other pictorial drawings exist, but we will continue with the rest next class. So, the isometric here, look, this is just a cuboid object, okay, that is drawn, and this is here the object drawn in isometric. What is the isometric, if you remember? We have the first edge, and we have these two axes at 30 degree. And these lines are parallel to each other, these lines are parallel, and all the lines go at 30 degree. This is the basic construction of this type of pictorial, which is called an isometric drawing. It is used a lot in engineering drawings. Always when there is orthographic multi-view, we can see isometric also used. Now, but this is not the only one. We have an axonometric drawing that is at 45 degree. Now notice this is the same object, but drawn at 45 degree. Look the way, the difference. The upper surface here, we can see it more tilted, and we can see more detail of the upper surface. So why do we need this and other types? Because sometimes, it depends on what are you drawing, okay? What are you trying to show? Sometimes you need to show more of, for example, what's in this area, more from the upper surface. If you're drawing, for example, a room that's open, you need to maybe show more details from here. This one is a little bit laying down at 30 degree. Not all the details are as clear as this. So it really depends on what you are drawing and which type to use. Now here we have another one, okay, similar, but at 30 degree. So this one, the whole is tilted from here 30, from here 60. So again, depends on what is your need for a specific drawing. All of these can be used in engineering drawing as a pictorial to express the ideas more clearly. Okay? Now, there is other types as well. There is the oblique drawings, and there is two major types used in engineering drawing, which is oblique at 45 degree in general, and this distance is shown half of the real distance, and another oblique drawing that is drawn at 30 degrees, and this distance is shown at its real size. Now, this one can also be a 45 degree. We will see that next class. It's not a problem. So I can put this 45 and this half distance, this 45 and full distance. But the main thing is that in one type, this is shown the real object, its real size, fully, and here at a half distance. Why is that like that? We will explain more about this later. Why do we have this? Now, so these are the major types that you will see used in engineering drawing, major types of pictorials, okay? Now the most common, well, we will talk about this a little later. Let me just cover these very quickly. These, we already know what they are. They are also pictorials, but they are drawn in perspective. So we have 1 point perspective, that the lines go towards 1 point. We have 2 point perspective, and we have something called 3 point perspective. We didn't discuss this in the past, and we will not discuss any of this now, because perspective drawings are not used in engineering drawing. Because, why? Because when you have a perspective drawing, for example, going towards a vanishing point, everything going towards the vanishing point becomes smaller and smaller and smaller. It's beautiful pictorial, but it's not accurate. It's not used in engineering drawing, because we cannot visualize, okay, if I have something here, it becomes smaller and smaller and smaller, but in reality, this piece here is the same like this size. So it becomes confusing. While these drawings here are accurate, exactly, we know. Here you represent the measurements as they are 100%, no matter at the front, at the back, because the lines are parallel. Here, parallel, okay? Everywhere, notice the lines are parallel. Just the angle is different, okay? Here, we start with the front, like in the 1 point perspective, but all of these lines do not go to a point. They are parallel, these two axes, okay? They're parallel here, parallel, okay? So this is the difference in engineering drawing. All the lines parallel, just the degrees are different. And we can draw to scale. We can draw 1-to-1 scale, meaning the real size of the object. We can draw smaller or bigger, but it is the real measurements on the drawing. There is no perspective, there is no vanishing points, there is nothing getting smaller as it goes towards. Okay, so this is something you need to pay attention to. Now, the most common ones, all of these are really used in engineering drawings, but the most common ones are the isometric and this type of oblique drawing, which is with the half distance. Now, these I covered them very quickly today, but next class we will talk more about these and about these, okay? So today our focus is on this one, on the isometric, okay? Our entire class focused on the isometric. But so that you know that there are many types and we will cover them. So, what is an isometric? In an isometric drawing, we already know the object's vertical lines are drawn vertically, and the horizontal lines in the width and the depth planes are shown at 30 degrees. We know that. 30 degrees from here, 30 degrees from here. And all the lines, other lines are vertical. We already know this information, but here is given to you as a summary. So we have 3 axes, the width, the height, and the depth. The height of the object is the first stage, and then the other 2 are at 30 degrees. Like this. So, this is the start of an isometric drawing. The first edge line, okay? And this line go at 30 degrees, this line go at 30 degrees. Now, sometimes you will find, if it's visible here, there is a grid at the back. Sometimes you can find ready grids that one can actually use and immediately start drawing on it. Or you can draw your own grid, but you see this grid at the back here. Okay, these are all lines parallel to each other at 30 degrees. But there is no need to draw all this grid on a paper and waste all this time, because as long as you have your T-square with the triangle, let me show you to remember a T-square with this triangle. So, if I have here, this is the 30-degree angle, so I can draw here a line at 30 degree. I can move it this way, that way, and all of it up and down, and draw any line, and it will be accurately at 30 degree. If I want to draw the opposite line, okay, I just flip it and draw from here line. Again, I can slide it and move all of this up and down. So you don't need to draw an entire grid, waste all this time to, to do that, because you have your tools. So, so basically this is how an isometric drawing starts and looks like. Now, here are some examples and some basic steps of constructing. Here we have 3 views: orthographic, multi-view, front, top, right side. Okay? 3 views. Now, and we want to draw this object in isometric, as an isometric pictorial. Okay? So, always, I mentioned these things from the past even, when we were drawing a little bit freehand in the introduction to 3D design. I always told you that you start with the major, frame, the major cube or cuboid in which the object lays. You never draw details. So even here, you always draw first the cube or the cuboid, which is a rectangular object, inside which the object perfectly fits. So the height, for example, the length, the width, okay? So you take, for example, the height, it must be perfect here. This size, okay? This side, okay? So, and then you draw the box. After that, you start drawing more details. Look at this here object. You start defining what is this measurement here, and you start defining what is this measurement here, and draw this detail. After that, the smaller details. So you start with the bigger details, the major ones, the straight lines. After that, you start, if you have circles, for example, inclined planes, these things is the next step. You never draw an inclined plane before you draw the normal straight planes, okay? So, the straight lines come first, then, for example, we have this here, inclined plane. This is later drawn, because you need to find out the location of these points on the straight lines, on the straight planes, and then define it. So, all of this is later. Also the circles, if you have circles, for example, you already know how to start a circle. You have to start with a square, okay? So the square has to be drawn first, again straight lines, and then the circle inside. Today we will also cover precise steps in drawing the circle as an engineering drawing. Not like in the past, a little bit freehand. So, but it still remains the same rule that you start with a square. So, and all of these smaller details are added after. Then in the end, you just darken the object lines, refine details, and that's it. Okay? So these steps will be applied in all isometric drawings and in all kinds of drawings. Even if it's a freehand sketch, you start like this. You never start with details. Okay? Here is another example. This is a final object, and as you can see, it has straight lines, it even has some inclined planes. Okay, how do they start? Again, with a major cuboid object, okay, at the top. That's how it started. And then, slowly, the details started getting defined. So, all of this object is taken and put inside a cuboid object. And then the locations of this here is located, and this height is located, and then slowly this inside object here, these distances are located from here and from here. So more and more details added. After that, this part is located. Everything, notice, starts with the straight lines, okay? With the straight vertical lines. So if there is an inclined plane, this is drawn later. After that, the inclined planes are defined by defining these point locations. And more details added until it's finalized. So, you can have a look at it later in more detail to understand it. There is plenty of examples to look at here. So, here is another example of a multi-view orthographic drawing, front, top, right side, as we have, you know. And we need to, what? Draw it as an isometric. And I put you here all the steps. How does it start? Again, with a box. A box that perfectly fits all the three axes of the object, measurement-wise. You take it from the orthographic, you put it here. Take it from there, you put it here, into a box first. And then, now look, this is an inclined plane. Let's go back here and see. Look, this is here an inclined plane. You cannot draw this plane before you identify this height, which is the location of this point, and the location of this point. Once you locate these 2 points, then you can easily connect the plane. But how to locate this point and this point? Okay, so there is here a measurement, and from here to here, there is a measurement. So, the height here needs to be identified, and the measurement from this to the back, and then these connected, and here is your inclined plane. After that, more of the details is being drawn, okay? Again, taking measurements from the orthographic, and measuring here, all the lines at 30 degrees, don't forget, and later, any other left details, which is this here part, an opening, also everything is measured and placed. So this is a very simple object, actually, but to illustrate the example. Here is another one, a little bit more complicated, but still easy. But here you have these type of surfaces. You remember from the first class, they're called oblique surfaces. So they don't follow, the other planes. So they are like cut-throughs through the object. So these are a little bit different, but it is done in the same steps. So here we have a front, a top, and a side view of this object. So you can have a look here at the steps. You start always like that, the isometric. Then what do? You draw the box with the correct measurements, height, width, length, all of this stuff, okay? And then, look, you start that oblique surface, which is a cut through here, the last thing, okay? First, you will find the location of the points. So all of these details you need to identify, okay? The straight lines. And after that, after the points are defined, then we can connect this surface. So if I don't know the location of this point, and this point, and this point, and this point, I cannot connect and to draw this surface. So they need to be identified through the straight lines first. Now, circles. Now this after the class, I will explain here quickly. After the class, I will draw one of these so you can see the steps, how it's really done. Because you have to use a compass to draw this. There is no freehand here, okay? Like in Introduction to 3D Design. So when we draw circles, there is a specific steps that you need to follow. So of course, we have the square. Now we are talking about isometric drawing. So this should be a 30 degree here, okay? This is a square, a 2-dimensional square. So we have just one side here, a 30 degree. And we need to draw a circle inside. How to do that? Well, it starts like in the past, what we know. We have the diagonal from here, diagonal from here. then we find this line and this line. So basically, these 4 points, we still need to find them. But there is an extra step after, which is drawing this and drawing this, and then using the compass, okay, that will be placed in this point, the compass, and this will be drawn. After that, the compass will be placed in this point, and this is drawn. So these two are the same. Then, this point and this point that will be defined, you will place the compass in this side, draw this arc. And then you will place it here, and draw this arc. Okay? So, this is basically how it works. So, using this compass, but I will draw it on the board later for you to see again. Here is more about the circles, the same thing, basically, how to draw. You can have a look at it later. Any object that have circular part, first you draw the square, always, okay? Look, square, square, and follow the same steps, okay? And then, after that, if it's, for example, this shape, you connect the lines. If it's this shape, you connect the lines. So, the circles are very crucial to be accurately drawn. Okay. Now, this is an example with circular objects again. So, at isometric, 30 degree, 30 degree. Then, before you draw any circles, the squares are located. The location of the squares, exactly. Now, in isometric drawing, remember, everything is in its correct measurement. So, if this is in the middle, in reality, it will be in the middle in the drawing. So these spaces are all the same, because it's isometric, okay? Not a perspective drawing. So you identify the location of the squares, you follow the steps that need to be followed, okay? Then, using the compass, you will draw each circle. And now, okay, these circles are drawn, but in fact, they are like this object, okay? So we need to know the height of this object, which will be drawn as a cuboid. Look, this is a cuboid object before you draw the circular object. So the cuboid, which is here, the square needs to be continued, okay, according to the height needed. And after that, the second circle also drawn, and then connected. So you will draw the two circles and then connect with each other. And this height must be according to what is needed. After that, this is what the object final should look like. So this is another example. Here, another object. Again, we have circles, and we have some curved surface also. Okay? Again, even though we have a curved surface, we start with what? A box. Okay? So the curved surface should be located here. But this later we find, after we draw the circle according to the rules. Okay? This box must be drawn first, so we know the touching points of the circle. Okay? So we know the square, where to locate it. We cannot straight away jump to the circle. And then we can easily, after we draw that, we know this point and this point, its location, and we did the circle, and this is connected, and this is connected correctly, and then the final line connected. This box stays. These are the construction lines. Okay? At least in this class, you don't delete anything, because I need to see how you constructed something. I don't need to see a final only object without any construction lines. I will think it's copied from someone, okay? Then I will start searching from whom it's copied. So no, all the construction lines, the details, everything, how you build it, needs to be on the drawing. But with the correct line weight, light lines, not heavy lines, okay? Okay. Now, after that, more details are added, which is this object. It is drawn as a cuboid object, as a cube or cuboid if it's longer. Then, again, this square, the circle is drawn. Inside this square, the circle is drawn, and then connected according its size. So, very simple examples. When you look at them at home, like slowly, you will start understand, if you don't understand, of course. Now here is some examples of isometric drawings used in real examples. For example, a room. You can draw it with open walls and show all the details inside. And we know exactly the measurements of these because it's in isometric, okay? And as you can see, everything is drawn at 30 degrees. All the objects inside, the details are at 30 degrees. And with the correct measurements, but to scale. So, interiors, products can be drawn like that. Kitchen, okay? Other kind of furniture, anything basically that is going to be manufactured, made. And you as a designer, remember, you're designing for what? In the end, your design should be made, manufactured. If it just stays on paper, what's the use? So, whatever you're designing will be made, so it needs to be drawn accurately as engineering drawing and as isometric. It needs to be also drawn for a visual, for a pictorial drawing. Now here, if I look at this kitchen, I know exactly, because this is an isometric, not a perspective, I know that, okay, all of these are the same size. This is how they are in reality. Now, if I draw it in 2-point perspective, it will look beautiful, but these, as they go towards the perspective points, they will become smaller and smaller and smaller, and it can get confusing for someone who wants to make this. So he wouldn't understand, do they really get smaller or are they the same size? So this can create problems. That's why perspective is not used in engineering drawing. That's why they have these methods, okay? So it's very clearly shown, the measurements. More examples, again, interiors, buildings even, you can show what's inside in isometric. These are more sketches, more like sketches, okay? So for a sketch, it's good to have a, what do you call this, a grid at the back, because you're not drawing accurately with the tools. It's like a sketch, but I need something to guide me according the lines. So it's good to have a grid if you're drawing a sketch, just to visualize quickly. But later when you draw the final, you need to be very accurate, okay? So these are sketches in isometric. More sketches in isometric. As you can see, even though it's a sketch, still the same principles are used. So before they draw the circles here, look, there is a square. You see, and there is another square at the back and another square because we have a lot of circles. And look, the center points are found. So the same method so that it looks correct, okay? Even though it's a sketch. Okay, so we have now our new exercises. Now, there are several things to do. The first one, now here we can see what? A front view and a top view of an object. Now, there's only two views here because we said in the past, if it's a very simple object, sometimes we don't even need a lot of views. Okay? So here, this is enough. Front, top, it's very clear what it is. Create an isometric pictorial of this object. Do not put measurements on the isometric drawing. So, you will take the measurements from here, but when you draw the isometric on the paper, do not later put me the measurements on the isometric. But if I take a ruler and I check, for example, this is what scale? Scale 1 to 1, so you have to use the same measurements. So for example, this is in millimeters, so this is here 5 centimeters, 7 centimeters. So if I measure the isometric, it should be the same. But without you drawing me the measurements, okay? Great. Do not delete construction lines. So when you draw this object, look at it, how it looks from the front. It has an inclined plane, it has this shape, but first you will draw the box. This is what you will draw first. Do not delete the box, do not delete anything, okay? Great. So this is a simple object, one sheet. I need to see it in isometric. Do not draw these. No, just the isometric alone. Okay? Some of you understand, but some of you will do exactly the opposite of what I said. I have to be as detailed as possible because even though I explain, even though I record it, some students still not hearing properly. So this is a problem actually. Okay, now the next exercise. We have another object. Again, front, top view. But here we have what? A circle also. And we have here an inclined plane, okay, that looks from here, from the front like this, from the top, as it's rotated at third angle, looks like this. Okay. Now, this object, before you draw it, again, how you draw? You draw the entire square, okay? The entire square you draw. After that, this arc here, which is, what is the radius? 31, okay, here. What is this mean? 3 centimeter, because it's in millimeter, okay? And this one here is what? This is the diameter. Because we explained before, when we have a circle, it is shown in diameter. When we have an arc, it is shown in radius. So the radius from here to here, okay? Now, this measurement from here to here, we already know. This from here to here is the radius of this arc. Scale 1 to 1. So, what you have here, you will place on the paper. Units used here, millimeter. And the same thing, okay? The same thing like the previous, just here we have the circle added. So when you draw the isometric, be careful how you construct the circle. Okay? And it's not only a circle, but it goes up, so it has a height, and another circle on top. So 2 circles, like the examples we've seen. Let me see here, here is pictorial. Okay. Now, here, it's a little bit different, this exercise. Here we have multi-view. Excuse me, who's talking? Front view, top view, right side view. Here, you need to draw the isometric. But, compared to the previous exercises, you have to draw this and this and this also. Okay? So these need to be drawn, scale 1 to 1 on the paper, and then in this corner you will draw the isometric of these views. Okay? On the same sheet. And you need to put the measurements as they are. Okay? Any questions about this? No. Now, we haven't finished. What? We haven't finished. I said that after the lecture, we will draw the circle, so that you can understand it. Now, let me see here. Now, forget what's here, just focus on what's here, okay? Let me see here. Okay, so in the past, in the basic introduction to 3D design, what did we used to do? How did we draw circles? We started with square, we draw the diagonals, then we draw this line and this line to find these 4 points. 1, 2, 3, 4. Everybody knows that. And then freehand, you used to draw the circle, okay, that touch these 4 points. So these 4 points touch the circle, okay? So you used to draw these, you used to draw freehand. So how, when we put it in isometric, for example, how did this work? So we have diagonal from here, then this line, perpendicular, go down through the center, this line, parallel, if it's an isometric, going through the center. So here are the 4 points that we need. Okay? And you used to draw the circle freehand. So I used to tell you, okay, now it needs to touch the 4 points, and everybody used to do this. Okay? So something like this you used to do freehand. Now we don't do that, okay? Now what do? We have the same steps, but an extra step here. So, okay, let's put this into isometric and see what will happen here. Let me use another color. So, we have to start diagonals. Here is the diagonal. From here to here also. Okay. Then, straight line down from here, parallel to these lines, okay? And from here also, a line that is parallel to these lines passing through the center. Now, this point and this point, and this point, and this point is defined again. Great, but we have a new step now to do. Okay? So the new step is from this corner, touching these 2 points. Okay? Okay, we will draw. So from this corner, we will place straight lines touching these 2 points that we already found, okay? And from the opposing corner, from here, again we will do the same, but touching these 2 points, okay? So it's very simple. Touching this point and this point. Now, look, when these 2 cross here, we define this point and this point, which is very important, okay? Now, with the compass, of course this is not going to work here, but just to show you in general. So you need to open it, place it here, okay? And it needs to go, the compass needs to be opened until this edge, okay? Here, until this point. So, the compass starts from here, placed, okay, open until here, and then you draw the arc like this, okay? So the arc will be like this, okay? Now, you do the same opposite. So starting from here, the length of opening the compass here, and you draw the other arc here. So it will be like this. So it needs to start at the point, end at the point. And this one, start at the point, end, okay? Okay, now, from these points, these 2 points, again, you will place your compass here, and the length, how much you open it, should be according to this, okay? So this and this will be the same. When you draw it accurately, I mean, they will be the same. So you open the compass, and you draw the arc like this, starting from this point. Then you do the same from this point. And this line and this line, this line and this line are the same. So it's basically the same arc you will draw, but from the other side, okay? And it will look like this. So these 2 will be the same, these 2 will be the same in isometric drawing, okay? So this is how you draw it correctly. So there is no freehand drawing here. So that's it basically.